Hello everyone, today we continue our journey into OpenSience by exploring the CMS experiment. On last video, I just recommended the meaning of simulated dataset names. After understanding the names, let's talk about the different parts of LHC performance. There are two parts of LHC running stages. The first is run 1, and the energy in the run 1, the first is about 7 TeV, and the center of mass energy. It means the two particles, proton and antiproton, is about 3.5 TeV respectively. Then the LHC increased its running energy to 8 TeV, also means two parts, each is 4 TeV. And after the run 1, the LHC upgrades the equipment and to get 13 TeV higher energy. And also there are two types of data the group used. The name is AOD data and mini AOD and also nano AOD format data. From this page we can get more about the information which like cross-section and phase space cuts towards each process. To mention that the calculation of color sample may be different on the run 2 using Jan-Char analyzer. Maybe because the data volume is so large, further comprehension and optimization was needed. It's also about the simulated datasets. After that, we can see this page, learn about the search tips. We can use the keywords combined with the and, or, and comma, these notes to search on the website. To learn more details about the different parts of the experiment. And then you can follow these examples to try the search skills. On the next page, I prepared to talk about the spectrum. After we find the data set on the website, and we can try to download them, such as this one, the AOD format primary dataset. We can see the volume of the data is so large, about several hundreds of GB. And also we can just download one of them to just glance at these ones. And how can you use this data? We can follow the getting started part and use the virtual machine, or we can use the Docker. We can use the Docker technology by different CMS software version, and I recommend the this one, the CMS SW 5332, this one. You can find the Docker on Docker Hub or GitLab. To deploy the computer environment, analyze the data from 2011 to 2012 proton-proton collision data. And after using the Docker environment, have some analyze steps. And then we can find the spectrum. Different spectrum means we can organize these data to form chart and pictures, get the human-friendly physics expression. Here is an example. It gives the code to produce a dimu spectrum. This simple analysis example is set up research level, and we can easily get this picture by the website visualize function, visualize page, such as this one, CMS histograms. There is a tab and we can select. In this tab, we can see there are several energy parts. There are many parameters we can select. The main purpose is to show the invariant mass of dimu events, dimu1. And we can use the log axis to have this human-friendly chart, and we can see there are two peaks on this line. The first peak is about 3 GeV, and the second peak is about 10 GeV. The first one means the GePsi particle, and the second one means the epsilon particle. And there are the other parameters means the validation information. Because this one is an official example, so it was already validated. And also we can select the dielectron events. And we can see the peak is already here. And here. Also, we can talk about W bosons. Because the neutrino is hardly detected on this experiment, so we can see there is the missing energy. There is the missing transverse energy, which means MET, and also the MET was combined with the phi angle, so there also the phi MET we can find on this example. And of course we can get the idea directly from these parts. Maybe the W boson invariant mass is not easily to define on the experiment. Okay, these pictures are the spectrum we want to get from the open data. Okay, that's it. Go back to the main page. I have prepared many pages to further discuss the CMS experiment. As we can see. Oh, here you can see we can use the more than 5 petabytes of open data from particle physics on this website. It's a real journey from getting started to giving up. So thank you for watching.